Hello, welcome to an electronic home workshop. In this workshop, I will be using the fundamental discrete components of electronic, which are diode, capacitor, transistor and resistor in design electronic problem or in project. I may also introduce something called the BC, meaning block circuit. Through my video, you will come to know the importance of this block circuit, what really they are, what actually they can do in electronics. Now, in this video, we are going to talk purely about latching. You will come to know and understand, and also the practical electronic application of latching. But first, what is latching? Latching is when you input a certain voltage into a component or a device, and that voltage is not enough to switch on the component or to run the device. What you will do, we will have to increase the voltage so that it will be able to switch on the component or to run the device. Now that we have increased a certain amount of voltage into the component or device, it now switch on the component or run the device. But if this certain amount of current or voltage that we have added to the normal current is removed, the component will still stay on, or the device will still be running despite we have reduced the current or the voltage to the normal voltage, to the initial voltage. When this happens, we call it latching. Now there is something you will have to achieve before you can latch a component or even a device. Now that actually is what we call a tug. Now, what is actually a tug? A tug is when two equal forces are made to pull each other apart in opposite direction. Now, when this happens, those two forces will not be able to pull each other apart either. They will stand still in the same position, struggling, fighting, shaking, trembling to pull one another, but they cannot. I will use a particular diagram to really explain what is tug, so that you will understand how to create a tug in a component in order to latch that component or device. Now, I have something like this. This is just a truck, and I have another truck like this. Like this, these trucks are being held together by a chain. We have truck A and truck B. This is the direction of truck A and this is the direction of truck B. We have something like this, the tire. Now, both trucks are tied together. Since they have no velocity, they stand still. They are not shaking, nothing is happening, they are not trembling, because they don't have any velocity applied to them, so no force they have anything. So what will happen? But suppose we'll actually give them equal forces. Let's say we give this 10 meter per second and these two 10 meter per second. Now when these two trucks are given the same velocity, they are using the same force to pull each other apart. A will try to pull truck B, and truck B is trying to pull truck A in opposite direction, but they cannot because the velocity that they are using to pull each other apart is equal. So they will stand still and they will be struggling, they will be shaking, trembling, trying to pull each other apart, but they will not at all not. When this happens, meaning you have created a tug. Now I will use a relay diagram to show you how you can create a tug in a component or device in order to latch that component or even the device. Now let me use the relay circuit, although it is not the real diagram, circuit diagram of a relay, but this will help you to understand better. Now we have something like this. I also have something like this. I have the middle pin, and I have something like this. I also have something like this. I labeled it C, meaning the common to this output. Here is 2, here is 1, here is 2. Here is contact name NC, normally close contact. Here is NO, normally open contact. Now let me explain exactly this circuit. Now the relay has two contacts. It has the common here and it has two contacts here. These pin 1 and pin 2 are just the output of this contact. Now if you power a voltage here, and here is the negative, current will flow from this point to this point, leaving this point, because here is also open. Now why this is normally closed and this is normally open? Because the switch here is making this contact, leaving here open, so here is closed. So it is normal when the relay is in normal state, meaning the relay is not actually energized. And when the relay is not energized, we have two features here. It will actually make this contact called the normally closed contact and open this contact called the normally open contact, so that power will move from this point through pin 1, which is the output of contact NC. But when the relay is energized, meaning the relay is not in its normal state because it has been energized, what will happen here? This pin will move from this contact to make this contact. Now if we input a voltage, the voltage will pass through this point and out of pin 2 back to the battery. Now what is our motive here? Our motive here is to create a torque. Now we have two forces that is acting in this circuit. One, the force of the spring that is holding this pin to this contact, and we also have the force of the solenoid, which we try to attract this pin from this contact to make this contact in order to switch on the relay. Now we have actually recognized the two forces. Now let's assume the force of the spring is 4 Newton. This 4 Newton is the force that the spring is using to hold this pin to this contact. Now we have the force of the solenoid. So for us to create a force, a torque, we have to make both forces equal. Now what we will do to equal this force? Now suppose we input 12 volts into this solenoid. the solenoid is directly going to create a magnetic field with a higher force that is greater than the force of the spring, and this spring will move automatically from this point to this point, and we don't want that. All we want to do is to input a certain amount of current into this solenoid so that the solenoid will develop a magnetic field with a force equals the force of this spring, which is 4 Newton. Now, how to do that? Actually, now we are going to connect a resistor in series with the solenoid inside the relay package. Let's say the value of this resistor is 560 ohm resistor, and now we have input a voltage here. A certain amount of current is going to pass through here, but remember this resistor here is called a fixed resistor, and if any current is flowing through this resistor to this point, then this current is going to be named fixed current. The current is 1 milliamp and we call it the fixed current, and this fixed current is going to flow into this solenoid so that it can create a magnetic field that will also create a force equals the force of the spring. Now this 1 milliamp current, which is the fixed current, is flowing into the magnetics, into the solenoid. Now the solenoid has produced a force of 4 Newton. Now the force of this spring is equals to the force of the solenoid. This force is not going to pull this pin from this point to this point because their forces are equal. The force of the spring is fighting to keep this pin to this contact, while this other force of the solenoid, which is 4 Newton, is also fighting to attract this pin from this point to make this contact. But it will not happen because their forces are equal. They are fighting each other. They are struggling to do that, but it will not happen. And when this actually happens, we have created a torque because the force here is equals to the force of the solenoid. Now, if we want this pin to move from this place to this point, we will have to increase the force of the solenoid. Now, how to increase the force of the solenoid? We must increase the current that will be flowing into this solenoid so that it will develop a magnetic field with a greater force than the force of the spring, so that it will attract this pin from this contact to make this contact. Now, for us to do that, we have to create a bypass path. We will use a resistor to do that. Now we have the bypass resistor. This resistor is what we call the bypass resistor, which also value 560 ohms. Now, since their value are equal, this also is going to pass a current of 1 milliamp, but this current is going to call the bypass current, and this current is going to call the fixed current because it is being produced by a fixed resistor, and this is also being produced by a bypass resistor, so it is called the bypass current. Now, it was only the fixed current that was flowing in this solenoid, which created a force of 4 Newton. Now it is both two current flowing here, both the bypass current and the fixed current. So we have 2 milliamp flowing here. Now 2 milliamp, if 2 milliamp is flowing here, the solenoid would develop a force of 8 Newton. Now, since the force of this solenoid is greater than the force of the spring, which is 4, automatically this pin will move from this point to make this contact. And when a voltage is put to the common, the voltage will move this direction instead of this direction. Now, since the voltage, the force is greater than the force of the spring, this force is now able to pull this pin from this point to this point. Let's say this pin has moved from this point to this point, and when that happens, we say the relay has switched. Now this pin is already here. The other step here is to also recreate the torque, because when you do this, the forces are now different, so there is no more torque. So we want to recreate the torque again to make this 8 Newton of the 8 Newton force to come back to the 4 Newton. Now what we will do here is to cancel the bypass current. So if we want to cancel the bypass current, we will open this switch here. When we open this switch, then there is no current flowing here. Only the fixed resistor is actually allowing this current to continue to flow, because it is a fixed resistor, and then we have a fixed current coming out of the fixed resistor. So therefore this is cancelled. So only this fixed current is now moving in this solenoid, and therefore this force is also cancelled. So we have 4 Newton. So now, since the forces are equal, we have actually created a torque. But the question here is that, will this pin return back to its normally closed contact? The answer here is no, because we have created a torque. We already know that when two forces are equal, no movement is going to take place. They will stand at the same position struggling. So the pin here is not going to move from this point to this point, because their forces are equal. And when that happens, we have actually latched the relay, because we have made the two forces equal, and the pin do not move from this point to this point. It remains here. So we have latched the relay. How to reset the relay? To reset the relay, you have to make this pin to move from this point back to its normally closed contact. Now what we will do here, we actually create a bypass passage, a shutdown passage, short circuit passage. Now we have a certain amount of resistance which we allow certain amount of this fixed current to pass through here, or let's say all this fixed current pass through this resistor. If that happens, then there is no current flowing in this solenoid, so there is no force here, because no current is flowing. The current is being shorted to ground by this passage. So if there is no force here, then the force here is 0. So this force of the spring will now be able to move this spring from this point back to the normally closed contact, and we say we have reset the relay. Now let me use the relay itself, the physical relay itself, to see how to latch it on and off, how to relatch a relay, and how to reset it. Now I have a relay here which is labeled 12 volt to 24 volt DC. This can control a voltage of 250 volt AC with 8 amp or 10 amp of current. I also have this other component which is a rectifier. This rectifier can convert the AC input to give a DC output, meaning it will convert the AC to DC current or voltage. We also have two leads here. These leads are going to connect to the pin of the two contacts, the normally closed contact and the normally open contact, so that you will see the action of the relay when we latch or reset the relay. Now we have this resistor. This resistor is 560 ohm resistor. We are going to use it to create a torque in the relay. It is going to use to pass a certain amount of current that is not enough to switch on the relay automatically, but it is going to allow this solenoid inside the relay to create a force equals the force of the spring, so that a torque will be created in the relay. We also have to use this resistor as a bypass resistor, so that the relay will be switched. This capacitor, we are going to use it in order to stabilize the action of the relay when the relay is being latched and reset. We actually have 4.7 microfarad capacitor, which is 50 volts. Now let's move ahead. We have the relay here. Let's say we have the relay here. This is the relay. Place it here. And we also have the rectifier here. This is the rectifier. Now we are going to connect the relay to the rectifier. Now we use this to do the connection. Now we connect it to the negative terminal of the relay, of the rectifier here. We have to break it. We also have the middle terminal, which is the common input to the output of the relay, which is the normally closed contact and the normally open contact. Also have something like this, and then we are going to connect the positive terminal of the relay, but not directly, because we are going to use a fixed resistor to do that. Now we have something like this. This point is going to use as the switch. Now we are going to input This is the fixed resistor. Now, this fixed resistor is going to pass a certain amount of current, which is not enough to switch the relay, but it is enough to create a force equals the force of the spring in the relay. Now we connect the leads here. We also connect this one to this contact, and we'll tie both negative contact together and connect it to what? To the negative path of the rectifier, which is like this. Now we'll give it like this, and we'll make something like this, so that you will actually see the reaction when we latch the relay and reset the relay. Now we have the input terminal of the rectifier. This is the AC input. To input, this is the capacitor. To stabilize the action when we latch the relay and reset. We will also use this as the bypass resistor here, which is going to serve as the key to switch on, meaning to latch the relay and to reset the relay. Now let us power the relay, the whole system, and see what will happen. Now when we power the circuit, this green light illuminated switch on because it is at its normally closed contact, and here is off because it is connected to the normally open contact. Now we want to latch the relay. We will use this resistor. We will use this resistor in order to latch the relay. This is the bypass resistor that is going to input a current here that will make the solenoid inside the relay package to create a force greater than the force of the spring, so that it will be able to move the spring from this contact to make this contact. Now let's connect the bypass resistor and see what will happen. Now the bypass resistor is still connected here, and this has switched on. The contact here has opened and here is now closed. So what will happen? The force inside the solenoid is now greater than the force of the spring, and that is why this pin moved from this contact to make this contact, and now the voltage is flowing through this lamp. But in case we remove this bypass voltage, bypass current, Will the pin come back to this point to eliminate this? Let's see what will happen. No, it does not. And when this happens, we say we have latched the relay. Now, if we want to reset the relay, we bypass the current that is flowing here. Instead of here, we will now allow the current to flow here to the negative terminal of the rectifier or the relay. Now let's see. That means we have reset the relay. Now let's latch the relay. You see? Now let's remove the bypass current. It still stays. So that is what we call latching. You latch and you reset. You latch, you reset. You latch, you reset. You latch, reset. Thank you very much for your audience. Don't forget, this is my first video produced here on electronic home workshop. Make sure you like, you share, and then you subscribe. Thank you very much again for your audience for watching this video. Thank you, many thanks.